Okay, so a very good evening to all. I am Sahil Gaurav. Could you hear me? Can anyone verify?
Yes, sir. Good evening. Nice to
Yeah,
see
good
you
evening.
again in this session. This is Ramesh Kumar. I was previously taken class of solar photovoltaic design.
Okay, okay. Nice
Yeah.
to see you also.
Yes, sir.
So, first, let us let me introduce me first. So, I am Sahil Gaurav, a PhD student at IIT Guwahati, and I am going to take this live tutorial session for this course Operation and Planning of Power Distribution System. And the course instructor for this course is Professor Sanjeev Gangli, and he's from the same Department of Electronics and Electrical Engineering, IIT Guwahati. So before we start today's session, if you want to introduce yourself, you can introduce to me. Otherwise, it is fine also. So anyone, Ramesh, you can start.
Yes, sir. Sir, my name is Ramesh Kumar, and I am pursuing Master of Technology in Renewables Energy. I'm in second sem. I'm pursuing in from MP. I have around 15 years of experience, and I am working with Bureau Veritas in Vadodara, Gujarat. I'm living in also Gujarat region. Thank you.
Okay. Thank you, Ramesh. Any other one?
Welcome, sir.
Any other one? Ajmer Rana, Kalunath, Syamlal, Brind Raja, Ram.
जी my name is sir Ajmer Rana
Yes.
from Himachal Pradesh, sir.
Yes.
I am working in my name is Ajmer Singh, sir,
Okay. Okay.
from
Yes.
Himachal Pradesh.
Yeah.
Now working in HPSCB Limited as a lineman, sir.
Okay. Good. Nice. Nice to see you here.
Sir, good evening. I am Shyamlal from Himachal Pradesh, now working in Aparva Energy Private Limited as section charge assistant manager.
Okay. Nice to see you, Syamlal.
Thank you. Thank you, sir.
So, any other one want to introduce?
Hello.
Yes. Yes, you
Hello,
are
sir.
audible.
Good evening.
Yeah. Good evening.
Sir, my name is Kalunath Yogi, and presently I am working at Greater Noida as a assistant engineer in Noida Power for power distribution. And
Okay.
recently I have completed my BTech in electrical engineer. Now I
Yeah.
am completing this certificate for better knowledge.
Okay. Great to see you. Okay. Any other one? So, as I can see, most of the attendee are from the means like they are working, they are employee. I think Ramesh is he has also experience and he is currently pursuing MTech. Another one are like they are employee of a certain company. So I will call each and everyone by name. So don't please feel offended. You may be senior to me also. So so first I just want to tell you the books. Uh, this for this course, I hope this book is this book you can see lesson and planning of Electric Power Distribution Engineering by Turan Gonen. So this book is also available in this book is also available soft copy online, so you can refer this book. And the second book, this Power Distribution Planning by Ashley Wills. So for the reliability part, you need to refer this book. Another part, you can refer the Turan Gonen book, that is Electric Power Distribution Engineering, and the recent edition is third one. So these books are available soft copy online also, and otherwise you can have access of these books through any library. Now, what is the pattern? How I am going to take this session? So first, briefly, I will just take a revision for this tutorial session. Means what type of theory we need to know before answering the question. So I will just go through all the concepts and all the expression formulas, and then we will start to solve the session. And what I will do, I will just show the I will just uh, show the question, and you can also try parallelly with me in your notebook. And if you got the answer, you can type your answer in the chat box. So and in between, if you having any doubt, then you can interrupt me and ask your doubt. And another thing is that if you have any other doubts regarding personal, if you want any doubt to be addressed personally, then you can contact me through this email ID. So this is my email ID, sahilgaurav@iitg.ac.in. So if you have any other doubt or concern while you are while you are reading or going through any part for this course, you can contact me through this email ID. So let us start today's session. So I will just show you what are the course content for this course operation and planning of power distribution system. So the first one is introduction and overview, in which we have seen this how the power delivery system, what are the structure of power delivery system, and what is the history of how this when this power system came into picture, and how the flow of power happens in the world. And then we will go through this module 1, load characteristics and load management. So till this part, load characteristics, we will see in this tutorial 1, and after that we will see in the subsequent tutorials. And then module 2 is power distribution network and overview, where we will see various types of distribution networks, and where we will see many terms and terminology. And then we having the reliability assessment of power distribution networks. So, and then in the same module, we are having this power quality issues of distribution networks like SAGs, fuels. And then we will, in module 4, we will see the load flow analysis of radial distribution network, where we will see this forward backward load sweep method that is done for this distribution network. And in module 5, we are having this reactive power compensation of distribution system with shunt capacitor. So this module 5, I hope this part, most of the part you have gone through for this undergrad course. So the similar concept we will apply for the distribution system also. And in module 6, we are having this power distribution planning, where we are having economic aspects. And then in part 2, we are having different models and solution strategy. In solution strategy, we will see this most of the techniques are optimization based techniques. So we will see this in the power distribution system planning, and then we will see the reconfiguration of power distribution network. So what are it? Why we need reconfiguration, and what is the best optimal reconfigured power distribution networks? It is also one of the optimization problem. And then in module 7, we will see some recent topics like distribution system with distributed generation, so DG, and energy store system. And at the end, in module 8, we will see this distribution system automation and smart grid. So module 7 and module 8 are, moreover, these are some research based topics, and this topic is a advanced course only. This course is advanced course only, but this module 7 and module 8, these are having moreover related with this how you can say this research based recent topics, and other ones are having this conventional things we will study till module 6. So let us begin with this revision of the concept and what are expression we required for this tutorial one. So most of the things in this tutorial one are theoretical based, and in this tutorial one we need only one expression, that is load factor. So we will see at the end what is the load factor, and another things are just theoretical part only. So the first thing that why do we require interconnection of power system? So what do you mean by integration of power system? It means that we are having thousands of generators that is operating in synchronism, and all are operating at one frequency. And what are the advantages of interconnected power system? So obviously we having better reliability and better economy. So we don't have if we having isolated power system, if we are having different we are having different regions of power system, then we have to put some, how we can say, we have to put some a spinning reserve, like in the we cannot take the power from the other regions. If we are having the technical power system, we can have the better reserves of power. So that's why it is having better economy also. Now coming to the history of electric power. So this first electric power came as DC system, and this was invented by Thomas Alva Edison. And this electric power system, DC based electric power system, first applied in Manhattan, USA, that is supplying 59 customers. And then subsequently, just in between 2 or 3 years, this AC system developed by Tesla. And this Tesla is associated with Westinghouse. So there is bar between the DC system and AC system. There has been like in history, this is one of the in technology this is technology war which should be adapted for delivering power, either DC or AC. So this is one of the technology war happened between this Thomas Alva Edison and Tesla. And finally, this initially this DC system was proposed because at the time we don't have the transformer. And just in few years, this transformer invented in 1885, and this AC power system gained popularity because we can change the voltage level, and we can reduce the power loss. So that's why this AC system just bound the bar, and AC system has adopted in the world. But if you see right now, we are again having the HVDC system due to the incorporation of due to the invention of power electronic converters, right? So HVDC again having advantage because uh, we are having less number of wires, and uh, uh, and due to this power to converters, this is feasible. Otherwise, this DC system cannot be feasible without the power to converters. So when this now this restructuring of power system, the prime goal is to separate out the activities of generation, transmission, and distribution. So initially, this whole power system is assumed as one system, while this power industry needs to restructure such that we can separate this generation, transmission, and distribution. So what happened that each utility is reformed with 3 companies and each operates independently. And for that is Genco, generation company, Transco, transmission company, and Discom, that is distribution company. And if you see in the Indian scenario, this Indian power industry is restructured with the implementation of Electricity Act 2003. And this implementation of Act eliminates the licensing of setting up a generator plant, and it imposes open access to of transmission capacity, and it also provides the facilities to customers that we are having different types of utilities that we can choose. So till here, any doubt you can ask, otherwise I can move forward. So the next part is the definition of power system. So the power system means all aspects of, according to section 250 Electricity Act 2003. We know that this power system is the system that consists of generation, transmission, and distribution. And this supply of electricity includes one or more of the following, namely this generating station, transmission lines, substation, tie lines, load dispatch activity, distribution lines, electric supply lines, overhead lines, service lines. So all these things constitute the power system. And if you see broadly, this constitutes of generation, transmission, and distribution. The power system is the system that constitutes generation, transmission, and distribution system. So that we call as power system. So now, if we see this, how this evolution of Indian grid happened, and how this became one nation, one grid, one frequency. So before 1991, we are having 5 regional grids, and these regional grids constitute of different states. Different states forms a grid that we call a regional grid. So before 1991, in India, we have 5 regional grids. 5 regional grids means 5 frequency, and these grids are not interconnected with each other. So NR means northern grid, and this NER northeastern, then ER eastern region, and then SR southern region, and WR western region. And now in October, then in October 1991, eastern region and northeastern region, they are connected. And then now the India has 4 regional grids: western region, northern region, and southern region, and eastern and northern region combined. And again in March 2003, after long time, this western region and with eastern region all are connected, and they will consequently called as central region. So this yellow part is called a central region. From the March 2003 onwards, we are having 3 regions: northern region, central region, and southern region. And in August 2006, this central region is combined with northern region. So this whole becomes central region. And now from this August 2006 onwards, we have 2 regions: central region and southern region. And in December 2013, after 7-year gap, we are having this central region and southern region are combined, and it became one grid, one nation, one grid, one frequency. So right now we are having one nation, one grid, one frequency. This whole grid is interconnected. All right. So now coming to the next part, that is power delivery system. So power delivery system, we also call it as transmission and distribution system. And if you see this structure, then as we all know that we are having generating stations. Suppose we are having 4 generating stations and each capacity of 500 megawatt, and it is generating power at 10 or 20 kV. So we require a step up transformer to transmit at higher voltage level. So then we are having transmission system, and typical voltage level for transmission system is 765 kV, 400 kV to 20 kV. Then we are having transmission substation that constitute this again a step up transformer. Sorry, this a step down transformer. So we are having this transmission system came, and this typical voltage level is 132 kV, 110 kV, 66 kV. Now again this connected with distribution substation that constitute of many things, but it also includes this a step down transformer which is which lower down the voltage, and it is connected with primary distribution system, and typical voltage level are 33 kV, 11 kV. And then we are having secondary distribution system that operates at utility voltage, and the utility voltage is 400 volt 3 phase or 230 volt per phase. So this is the electric schematic of power delivery system. So whatever we are power generating at some voltage level, we are doing the step up such that we can reduce the power loss. How we can reduce the power loss? Because we are transmitting the power at a higher voltage level. So we know that this power is constant, and if you are increasing the voltage level, this current will reduce, so the power loss will reduce. Okay. So here you are telling this electricity law. Which law you want to ask?
Sir, please elaborate the evolution of Indian grid electricity market. Just you had shown in the left side of the open access power exchange imbalance.
Okay. So this you can refer this POSCO website.
Okay.
Electricity market. I've not gone through it. I just
Okay.
take the picture from there.
Okay, sir, no issue.
Any other doubt?
No, sir.
So this is the typical. This is the structure of power delivery system. So this one is very important. If you are a power system engineer, then one should know how this power transfer from the generating station to the customers, to the small consumers, or how it provides to the large customers also. So now let us come to the single line diagram. So single line diagram is used for tracing this power transmission distribution network, and we have to assume this balance system. We cannot draw single line diagram for unbalanced system, so we have to, if there is balance system, we can draw the single line diagram. And this one of the example is shown over here. Here we are having generator, then we are this transformer, and then bus 1, and these 3 lines shows these 3 transmission lines, and then we are having transmission line, and bus 2, and then we're having transformer again and sub transmission line, and then we are having this transformer and distribution line which are connected to the different loads. Now, if you want to draw structure of a transmission system, that is usually a mesh system. So the structure looks like this one. So in mesh system, we are having different power flow path, while in the radial system, we are having single power flow path. So here we can see that this if one generator goes out of service, then this line can energized from this generator 2 or generator 3 also. So in mesh system, we are having different power flow paths, and if you see the radial system, we are having the single power flow path. So here this structure of distribution system, which is usually of radial in nature. So I have shown over here starting from the distribution substation and the voltage level, and here we have taken this voltage level of 11 kV, and then these are having different this is the main feeder, and in the main feeder we are having different nodes, and at different nodes we are having different loads are connected. So this is the structure of distribution system where we are having radial feeders. So here we can see that there is single power flow path. There is no other there is no other power flow path to the loads. Like this, all power will come from for this, like the load connected at node 2. This power will come through this path only. Now coming to this, how we can difference between the transmission and distribution networks. So transmission network are usually of mesh type and distribution network of radial type, and in loads relatively balanced because it is spread over a wide region. That's why you can assume it is balanced. While distribution network, it is usually unbalanced, and we are having uh, customers of single phase. So usually it is of unbalanced type. While this in transmission network, where lines are transposed in nature, while distribution network, the lines are non-transposed in nature. Transmission network power losses is usually low, while in distribution network power losses is higher. Fault occurrence in transmission network is less, while distribution network is more. And RX ratio is low in transmission network, while it is high in distribution network. So coming to this next part. So what is the here we have coming to the load characteristics and load management. The first question comes is that what do you mean by electrical load? So the typical answer given by the students are that load is resistance or load is impedance. So an electrical load is a device which consumes certain amount of power energy to accomplish certain task. The correct answer is that we have to correlate electrical load always with the power. Means higher load means it is consuming higher amount of power. Lower load means it is consuming less amount of power. Now here the second question that for the given circuit, what should be the resistance to increase the load? So what is the correct answer? If you want to increase the load, will the resistance reduce or increase? And you can type the answer in chat box. Yes, this I had extracted from the third slide only. So resistance R reduce so that power consumption increases. If you reduce the R, current will increase and this power VI will be increased. So that we can increase the load. So important thing is that electrical load you cannot characterize by the resistance or impedance. We have to always characterize by this amount of power. What amount of power is consuming or delivering. What amount of consuming, sorry, it is load, so it is consuming. So greater amount of power, that means higher load, and lesser amount of power means it is having of lower load. Now coming to this different types of loads based on the dependency of voltage. So there are three different types of loads. First one is constant power load. As the name suggests, this constant power load means power is constant regardless of voltage. Like an example is electrical motors. So if you increase the voltage, then current will reduce, so that this power will be same, power will be constant. And if you reduce the voltage, then current will increase. An example for this constant power load is electrical motors. And the second type of load is constant current load. Here this power is proportional to voltage. How it comes? We know that this power is proportional to VI, and if this current is constant, that means power is directly proportional to voltage. An example for this constant current loads are welding units, smelting, and electroplating processes. And third type of load is constant impedance load. And here power is proportional to voltage square. So how it comes? We know that power is directly proportional to VI. So we can write I equal to V upon Z. So power is directly proportional to V square. That's why power is proportional to voltage squared. And examples are incandescent lighting, resistive water heaters. Now coming to this load curve and load duration curve. So load curve means that is electrical load demand that varies with time, and the plot of load demand with respect to time is known as load curve. So the first figure shows the load curve. Here we have shown with respect to time. It starts from let us say 12 midnight. So it starts from 12 midnight and it goes. It has divided into some. It is divided into some time period, and then we are having load demand till that time period. For that time period, we have calculated, and this plot is made. And this load duration curve is not with respect to this. Is not with respect to time varying. It is respect to with the descending order of load magnitude. Means for this is 12 midnight, so it is 12:15, and it is 12:30. So on. It will go for whole the 24 hours, or like 12:30 and 1 o'clock. Twelve thirty, 1 a.m. and so on. While this load duration curve. We have recorded this load curve, and now we have arranged this in descending order. So this one is very important. So we have arranged the load curve in descending order in order of load magnitude. Means the first comes at the higher load magnitude, and this part, if you see this part, I think it is morning hours. So this part first comes, and then gradually it decreases. So it is recorded form of load curve based on descending or load magnitude. And if you see this area under load curve and area under the load duration curve is same, and it will provide the amount of energy consumption. So now let us see this last part where we will see this load factor. Load factor is the ratio of average demand to the peak demand, and it is very important. So just remember this expression. It is the ratio of average demand to the peak demand, and it is always less than 1 because this average demand cannot be greater than peak demand. And if you assume this as taken as equal, like here we have assumed this average demand equal to peak demand, then it makes a hypothetical load curve, and it does not exist. So that's why this load factor is always less than 1. And what are the important fact points regarding load factor? This load factor should be near to unity, and that is preferred to the utilities, because this average demand and peak demand should be close to each other so that they can better estimate the power demand. The utility companies can better estimate the power demand. So the utilities always prefer the load factor should be near to the unity. And this load factor is lowest for domestic type of load, while it is highest for the industrial type of load. So this second point is also important. This load factor is lowest for domestic type of load, while it is highest for industrial type of load. Because in this industry the power is not fluctuating. The power is not fluctuating that much over the period of time. While domestic, this power is fluctuating based on the needs. Means say in the morning hour, we are submersible is running, so maybe this higher power demand happened, and as the everyone goes to a school or offices during the working during after 9 o'clock, then power demand may reduces, and then again in the night time, this power demand again increases. While for industry, they know that all the equipment should run over always, because this shifting of time happens for the employee. So it is always load average demand is nearly equal to peak demand. That's why it is highest for industrial type of load, while this load factor is lowest for the domestic type of load. So this is all for the revision of tutorial 1. Now we will solve the problem. Yes, I will share the PPT. I will share the PPT. I think if you know from where you will get the PPT. So I will just show you for this like I will show you the last year code, because this will updated after 1 or 2 tutorials. I think it will updated within this week. After the 2 or 3 days, it will updated. So here, if you see this problem solving session, this will come in some days, I think 2 or 3 days. So if you click this, Like here in course outline at lower, if you see this problem solving session, and here one it is showing this problem solving session recording. So you have to click that part. And here you have to go click here to view the problem session lectures. And here you can having this YouTube link and this presentation folder link. So in presentation folder link, I will upload all the PPT. So this time also, last time I was the PMRFTS. That's why I have the PDF of last year course also. So this time they will update in 2 or 3 days. So most of the questions are very easy for this tutorial one. So the first question is that the unit of load demand is usually given in, and options are shown over here. This is multiple select question. So more than one answer is correct. Those who know the answer can type their answer in chat box. Yeah, you can share. I think this time I have not made this Google Drive folder yet. So I will share you soon. Don't worry, miss. I think in 2 or 3 days it will come to this SWAM portal also. Yes, A and B are correct. Correct. Sabasek, you are correct. Your name is Sabasek or any other thing? So the unit of load demand is kilowatt and kilovar, and this kilovolt ampere and power factor. So if you multiply kilovolt ampere with power factor, it will give this power. We know that active power is apparent power into cos phi. So A and B are correct answer. Now coming to this next part, next question. The second problem is that a distribution system consumes 120 units of energy in a day, and daily load factor of the feeder is 0.5. Determine the peak load on feeder. If you are having any doubt, you can ask from the slides, or you can ask for the problem also. Kalunath has given as 12 kilowatt. Sorry, it is wrong answer.
Sir, please keep the question on the screen, sir. We are writing those questions.
Yes. Yes. A is the correct answer. Ramesh, you are correct. Yes, Sava, you are also correct. 10 kilowatt. Yes. So how it is also not a difficult problem. So in this course, I can say that one or two tutorials are little bit challenging. Another ones are like if you study well, then you can able to answer very easily. One unit of energy, we know that it is equal to 1 kilowatt hour. So 120 units of energy will be 120 kilowatt hour. Therefore, load factor will be average demand on peak demand. So load factor of the feeder is given as 0.50 and average demand we can find from the unit of energy consumed. So 120 kilowatt hour. So it should be divided by 24 hour because we have 24 hour in a day, and then peak demand is we have to calculate the peak demand. So it will come as 10 kilowatt. Right.
Hello. Another Purila. Okay. Okay. Bye.
A is the correct answer. MS Mukund Rajan, Mukund Rajan, yes. Please
Yes.
turn off your mic. Please turn off mic. At the time you speak, just at the time you unmute yourself. Otherwise, just mute always. So the correct answer is 10 kilowatt. I hope many of you have given the correct answer. Sava, Ramesh, both of you are correct. Now let us come to the next problem. So which of the following are the feature of power distribution system? Please type your answer in the chat box, and it is again of multiple select question. It is of multiple select question. More than one answer are correct. And the options are high Rx ratio, high RYX ratio, high power loss, balance transposed. Let me see the response. It's Nath Yogi, A and B, Ramesh, A and B, Sava, A and B. Yes, correct. High RYX ratio and high power loss. Since the resistance is high, so the current is also high due to lower voltage level. So this high power loss happen and resistance is high, so that this is high RYX ratio. Can anyone
What's the
tell
meaning
what
of
is?
transposed?
Yeah,
What's the meaning of transposed?
yes. Transposition of transmission line. I think many of you studied in undergrad course. So I will just briefly brief what is the transposition of transmission lines. It is happening in the transmission lines. It is not happening in distribution line. What happens is that if you send so this is your one end of transmission line, and if you send power to this transmission line, and this is very long. Transmission lines are usually of very long distance, and it is connected through different poles. I think many of you have seen while going through highway or trains. So in between we are having uh, uh, many poles for transmission of power. So what is happening that we are having different geographical uh, geographical structure for the poles. Like this pole, whatever this pole is facing heights or some twins, this pole will not face the similar. So what we usually do, So what problem happens if you send power from this pole to these poles? Like here, if you have sent this balanced voltage, you have sent the balanced voltage from this bus, and whatever the voltage you are getting due to different geographical constraint or different geographical structure, at the poles, you can say, you will get unbalanced voltage. So we are sending the balanced voltage, but we are getting the unbalanced voltage. So what is the solution? Solution is that you can transpose it, like this pole, this one is the A phase. Now what you've done, you have just changed its position. For the second pole, you have changed its position, and now for B phase, you have changed its position, and for C phase, I am not able to made it correctly, but similar type thing, such that each phase, like A phase, B phase, C phase, will face all the different structure of heights. So if each phase of lines will face all the structure heights at different position, then we are able to get the balanced voltage. Otherwise, what happens that different phase will face different height, and we will get unbalanced voltage because due to the different how you can say different power loss. So we will get the unbalanced voltage. So to avoid the unbalanced voltage at the receiving end, we do the transposition of line. So in one line you can write unbalanced voltage at the receiving end. We do the transposition. And you can just Google to see the picture of transposition. So this one, see, like each phase will face all the structure. 1/3 of the line length, A phase will be here, and 1/3 of line length, this A phase will be at this position, and 1/3 of line length, A phase will be at this position. Because at different structure, they will having different mutual inductances also. The inductance will also vary due to the position also. So to make the inductance for each phase, for each wire same, we do the transposition such that the drop happens through each phase will be same, and we will get the balanced voltage at the receiving end, right? Because this suppose B phase we will keep in between always. So this is having different inductance respective of A and C phase. While what you have done, you have done this B phase at different positions, so that we can having it will face all the position, and this inductance will be same for all the lines. Whatever inductance will come for A line, B line, and C line, all the inductance will be same. So we will having this equal drop for the lines from the each phase, and we will give the balance voltage.
We are changing this sequence at every pole. Yeah, we changing alternate, yeah, something, yeah, what?
This I am not confirmed, but this designing experts designing means we have to consider this one, like each line should be having the same inductances, and I think they are changing at every poles. Like here, if you see, they are changing the position.
Not on every phase, sir, every pole. It is the line length more than 100 kilometers. There we should place the transmission towers for one third of the line, more than 100 kilometers lines, transmission lines. There's
Okay,
special design of transmission tower.
if it is less than 100 kilometers, they will not change.
There will, yeah, right, sir. They will not
Okay,
change.
thank you.
Phase.
That I've told you, I'm not confirmed. Whatever I studied about transmission, I have not practically seen in the transmission line. I've seen, but I don't know.
Means we change after 100 kilometer, before 100 kilometer
If
the line.
if the line is more than 100 kilometers, then we change the phases. Means if the line is 150 kilometers, then we place two towers, transmission towers in the line. Means 50 kilometer, then next 50 kilometer.
Okay, I
Okay, below
understood. Miss,
100 kilometer we are not changing page,
Yeah,
right?
yeah.
Yes, okay, thank you.
Okay, thank you.
thank you, Syam. You're from which company, Syam?
I'm a Prava Energy Private Limited, and I have experience in transmission line.
Okay, very nice
I'm
to.
well.
Yeah.
Okay.
Great.
Which state?
I'm in now Rajasthan, Badmer.
Okay. Okay. So I hope so that's good, miss. We have having the expert also. So I hope you understood what is the transposition of lines. The conclusion that to avoid the unbalanced voltage at the receiving end in the transmission line, we do the transposition, and as this as what is the name? As Syam said, we do usually do uh, transposition for the transmission line above the 100 kilometer of lines. So now coming to the next slide, next problem. So the next problem is choose the correct statement, and here only one option is correct. The first option is distribution networks are more balanced as compared to transmission networks. Most of the distribution networks in India operate radially. Power loss in transmission networks are high as compared to distribution networks. And D option is most of the distribution networks in India operate as loop or mesh. You can type in the chat box. Yes. Ramesh, Sabha, Syam, all of you are correct. B is the correct answer. So if you see the first option, distribution networks are more balanced as compared to because most of the customers are of single phase type. Most of the distribution network in India operate radially. Sorry, this is incorrect. Yes, distribution networks are of radial in nature. C option is power loss in transmission networks are high as compared to distribution networks. It is incorrect. Power transmission happening higher voltage level and current is low in transmission network. So power loss is lower in the transmission network. D option is most of the distribution networks in India operate as loop mesh. No, this transmission network operate in loop or mesh. So B option is correct. Now coming to this fifth problem, which of the following are different types of loads based on the dependency on the voltage? And the options are constant temperature load, constant impedance load, constant current load, constant angle load. And this is multiple select question. More than one options are correct. So if you have theoretical type problem, then you will having many questions are of multiple select question, where more than one options are correct. And if you are numerical type, there is less chance of multiple select question. Uh, 1 minute, I am just Nath Yogi. You are correct. Well, if you put B only, then you will get half marks. And if you put one correct option with incorrect option, then you will B and C. It is very easy problem. So we have seen different types of load: constant power load, constant current load, constant impedance load. So this temperature load is not type of load. Constant impedance load. An example for this is building and smelting and electroplating processes. And constant angle load is not a type of load. Moving forward to the next problem. So the next problem is that total energy generated yearly by a power station is this much kilowatt hour and maximum demand on the power station is 100 megawatt. Determine the annual load factor. So you can solve parallelly with me, and if you got the answer, you can type the answer in chat box. So I am also solving here. Load factor. So load factor is the ratio of average demand upon peak demand. How you can write average demand? So they have given the total energy generated early. So this energy generation by early basis. So we can convert this into power. 438. How many zero are there? And you divide by number of days, 365 days, and 24 number of hours in a day. So this will convert into power. So this one is the average power demand. And maximum demand on the station is 100 megawatt. So 100 megawatt means you can write 100 into 10 to the power 3 kilowatt. Now you can find the load factor. So they are asking in percentage, so multiply with 100%. So 10 to the power 3, 0.5 into 100%. So it is 50%. So 50% is the correct answer. D is the correct answer. So how many of you still you are unable to see the question? Hello?
Now it's okay, sir.
Now, okay, we are able to see.
Okay. So this is no tricky type question. Just you have to apply the formula and you will get the answer. In now it is visible.
Yes, yes,
No,
visible.
sir, no. Yeah, now it's visible.
The question is hidden, sir.
Question is not visible.
No, now it has gone, sir.
Oh, no, my question is not coming to you.
Sir, again, now that the message is coming and going, sir.
Which type message? I think when I'm putting in
So
slides
this is
slow
fine, sir.
slides
This is fine. This we can see.
at that time only it is not visible. Okay, here in this problem, the total energy generation is given by power station. So they have given in early basis, and this maximum power demand is given. So here you can see this energy is given, and while this maximum demand is given in power, so you have to convert this energy generation into this power generation, average power generation. So how you will convert this energy generation in a year into average power demand, average power generation? Here you can write also so this much amount of kilowatt hour. So we know that in a year we have 365 days, and number of hours is 24 hours. So we'll get this average demand. So average demand is 50,000 kilowatt, and peak demand is 100 kilowatt, 100 megawatt. So we have converted into both into kilowatt and multiply with 100. So we'll get the moving to the next problem. So if we have very peak and small base load curve, then the load factor is, as options are poor, good, 0, 1. So let me see how many of you give the correct answer. So Sava, Ramesh, both have given A as the answer. Yes, correct. A is the correct answer. It is poor. Someone mic is turned on, please turn it off. Ramesh, turn off the mic. So all the question moves around this expression only. This load factor, we know that ratio of average demand upon peak demand. So if we are having high peak demand, so we are saying it is high peak demand and a small base load curve and page of lower, then load factor will be, so it will be poor. So A is the correct answer. Now coming to the next problem, distribution system planners need the data for load demand magnitudes, geographical location of
Again,
loads.
super.
Okay, so first let me write this is of multiple set question, and I will minimize it. Where more than one options are correct, so give the answer accordingly. Options are load demand magnitude, D is geographical locations of generators. So Ajmer, has given BC, have AC, I think. Yes, Nath, you are correct. A and B are correct. So load, demand magnitudes, and geographical load demand for a certain area, location of load. It they had done for distribution system. We don't have any relation with power generation and this location of generator. We have to deal with this generation side, distribution side only. So in distribution side, we have load demand profile. We have to know the load, what is the load demand at different locations. So this is the correct. What is the load demand and what is its location. So A and B are the correct option. So moving to the next problem. What is the load duration curve? And options are load duration curve with the plot of load demand with respect to time. Duration curve is recorded from a load curve based on the descending order of load magnitude, while C option is load duration curve with the area under load curve. D option is load duration curve with the plot of peak load demands of multiple feeders. It is not a multiple select question. It is single answer type problem. Type on the chat box for this problem number 9. What is the load duration curve? I am still not got any answer. Yes, Syam, you are correct. B is the correct answer. Load duration curve is the recorded form of load curve based on the descending order of load magnitude. And if you see the theory behind it, between load curve and load duration curve. Load curve is the load demand curve that varies with time, and this plot of load demand with time is known as load curve. And while this load duration curve, it is the recorded form of load curve based on the descending order of load magnitude. So we have to record the load curve and we have to arrange in descending order of load magnitude. We will get the load duration curve. So load duration curve is the, from this option, if we see B option is correct. Now coming to the last problem for this tutorial session. So here in this problem, residential. Now you can see the question or not? Shyam, Ramesh, any
No, sir, no.
A residential customer consumes 2 kilowatt for 2 hours, 1 kilowatt for 10 hours, and 500 watt for rest of the day. The load factor for this load is, and the options are 0.508, 0.625, 0.417, 0.395. So all of you try. No, A is not correct, Sava. So what is the due date for this current assignment? If you see the due date, I was opening another course. Every course has same the due date. So it is 5 of August. I hope all of you have noted down this problem. So the due date for both this first assignment and second assignment is 5 February, and our next tutorial class will be on 2nd February. So we will able to put the assignment before the due date, right? Because you have due date till 5 February. And on the 2nd February, many of you may have the GATE exam also.
Sir, this total load will be 20 kilowatt hour divided by 24 hours. So that will give us 20 by 24 kilowatts. That will become the average load. And divided by maximum load, that will be 2 kilowatt hour. 2 kilowatts. So it will be 20 divided by 48.
Yes, correct. Very good.
So that will come out
Sabha.
as 10 by 24, no?
Yeah, correct, Sabha. So
So
correct
it will
answer is
become
point four one six.
0.508.
No, 0.416. You have divided incorrect. 10
No,
by
10 by
24, how much?
10 by 24, no?
So 10 by 24, it is coming as 0.417. 0.41667.
Okay. But his answer is 10 by 4, 10 by 24.
Yeah,
20
you have
no.
divided
Only
incorrectly. 10
division
by
was wrong. Okay. Okay. Okay.
so total sector is average demand. Average demand upon peak demand. So average demand will be how much? Two kilowatt for 2 hours plus 1 kilowatt for 10 hours plus 0.5 kilowatt for rest of the hours. 10 plus 2, 12 hour, and then so 12 hours for 0.5 kilowatt. Now we have to divide by 24 to get the average load demand. So peak demand is 2 kilowatt. So numerator will be also kilowatt, denominator will be also kilowatt. So just check the unit also. So it will be 4 plus 10 plus 6 upon 24, and denominator will be 2. So 14 plus 6, 20, 20 by 48. So it is 10 upon 24 or 5 upon 12. So you will give 0.41667 approximately equal to 0.417. C is the correct answer. So till here we have completed the problems related to the last year assignment. Now we will just revise quickly. I have solved already all the problems because it is already covered in the previous tutorial session. So I will revise all the problems related to 2023 assignment. Till here we have covered the question related to 2024 course, and now we are going to cover this 2023 assignment problem. So I have already taught this in the previous year session. So just you go through it, and I will just quickly revise. We will able to complete at 8:45, and after that I will just open to this any doubt or concerns, and then we will close the session. So if you see the 2023 problems, so the first problem is that power delivery system consists of which of the following: transmission distribution line, substation distribution system, D, all of the above. So here you can see that all these whatever the things here written comes under power delivery system. So this correct answer is all of the above. And if you see the definition of power delivery system, it is named as transmission and distribution system that consists of thousands of transmission distribution lines, substation, transformers, and other equipments scattered over a wide geographical area and connected so that all function in concert to deliver power as needed to the utility customers. So the aim is to deliver power according to the as required by the utility customers. The next problem is that visual flying customer have higher load factor. So as I told in the beginning only, this highest load factor is for the industrial customer, while lowest load factor is for the domestic customers. There are three types of load: domestic, commercial, industrial, and agriculture type of loads. And the important thing about load factor is that it is lowest for domestic type of load, while it is highest for industrial type of load, because this average demand is nearly equal, means moreover equal to the peak demand. That's why industrial customers having the higher load factor, while this average demand very much with this in respect of peak demand. That's why load factor is low for the domestic type of load. So here you can write lowest load factor, highest load factor. And next we will see third problem. The load factor of domestic load is 10 to 15%. That is the lowest one. What is the goal of power delivery system? That is transmission and distribution system. And the options are capability to meet peak demand, to provide reliable supply to consumers, a stable voltage quality and desirable power quality, and these all of the above. So the goals of power delivery system are: it covers the utility service territory, reaching all consumers who wish to be connected and purchase power. It has sufficient capability to meet the peak demands of those energy consumers, provide satisfactory continuity of service to the connected energy consumers, provide a stable voltage quality, and maintain the desired power quality. So the desired things of power delivery system are: it should cover whole the territory, utility service territory. It has sufficient capability to meet the demand. It has reliability, proper reliability, continuity of service, and proper voltage quality and power quality, stable voltage quality and desired power quality. Power quality should not go beyond the constraints. Next question is that which of following is feature of power distribution system? First option is load resistant to reactance ratio. It is incorrect. It is higher for distribution system. It is of unbalanced nature. Yes, it is correct. It is unbalanced nature. Transposition is happening in transmission network. Lower power ratio is happening in transmission network. Which of following is our distribution substation equipment? Options are circuit breaker, isolator, impedance relay, distribution transformer. So circuit breaker and isolator comes under the distribution substation, while this impedance relay and distribution transformer does not comes under the distribution substation. Yes, I will upload all PPT. So I just show you the questions, because if you go through the questions, no question will come out from this range in either in your current assignment, either in the exam. So most of the question will cover all these things only.
Hello.
Yes.
So my question is that distribution transformers is also the part of 33 kV by 11 kV substation.
No. This is not distribution. It will not come distribution substation, because distribution transformer that we called as at the utility level 11 kV 400 volt. So that will not come in this substation. So it is higher voltage level. So
No, then where is this transformer distribution transformer is only 11 by 400.
yeah,
11 kV by
that
400
is,
volt.
yeah, that is distribution side, not
But
at the
30,
substation.
33 kV is the second primary distribution part of primary distribution.
Yeah, 33 is primary distribution side.
Then if the primary distribution of 33 kV, then distribution transformer is also include by 33 kV by 11 because we have to step down the voltage to 11 kV. Then why
Yeah,
it is not part of the distribution transformer?
but we don't call that is distribution transformer because it is inside it is inside
Yeah,
at the
speak.
pole. Hello.
Yes, sir. Yes, sir.
We don't call this distribution transformer that is available in the substation. That is have a higher voltage level, like this 33 1 kV, 11 kV. But we usually see the distribution transmitter at our residential side, like where see in a community or colleges everywhere.
Okay.
Is the distribution
So-
transformer secondary voltage always 440 volts, sir? Three phase?
400 volt, not 440 volt. Yeah, that is the utility voltage. So the secondary
So-
side should having 400
So
volt.
if the secondary voltage is 400 volt, only then it will be called as distribution transformer.
Yeah, I think, I mean, and distribution transmitter that is not available inside the substation. Yes, I think you are correct.
But sir, the transformer installed in 33 by 11 kV substation, what type
Yeah.
of that transformer? That is not the distribution transformer.
That we called it as general step down transformer, power transformer, but we don't call it a distribution transformer, as we have seen in this course.
Okay.
Sir, there is one more question that, sir, while explaining, I think he has somewhere, he has said that the substation rating is actually the rating of the distribution transformer itself. No?
No, substation rating is the transformer rating. That sir said, not the distribution transformer. Substation rating means like we have sub-trans.
Okay.
Whatever the transformer rating, that we call that uh, uh, what transformer rating, that is called substation rating. So distribution transmitter that we installed at the locals at the residence side, at the customer side. So that's why it is not called at the part of distribution substation. So it is
Means distribution transformer is always nearby the load.
yeah, you can say also. Okay, we have less time. So what is the hierarchy of power transmission system? Then we have sub-transmission system. Then we have primary distribution system, and then we have secondary distribution system. Now, transformer connects to the secondary distribution system, primary with secondary. You can save that one. While this substation that you are talking about, that is sub-transmission to primary distribution network. So here you can see this generation transmission. Then we have substation. So this is also substation. Here switching happen, and then this is substation also, and then we having, then this is the primary distribution network, and then we are having this secondary distribution network. So this we call as distribution transformer. So this one. So this the transformer installed at the pole, that we call it a distribution transformer, and its rating is 400 volt for 3 phase, while 230 volt for single phase. Its output is the secondary side. Now coming to the next problem. Here we have the maximum demand is given and load factor is 40%, annual load factor. So we have to calculate the total energy generated in a year. So you have to just apply the formula and you will get the total annual energy. So here we have peak demand, we have converted into this energy by multiplying with number of hours in a year. So number of hours in a year, 8,760 hours. So this kindly keep in your mind. You can directly put the number of hours in a year, that is 8,760 hours. So let us, for the exam, the question papers will not be to us. Like for the previous year exam question papers, we don't have. Just only the assignment problems we have. Residential customer consumes maximum of 2 kilowatt for this much. This similar type of problem we have solved right now. And this type of problem we have also solved. This is secondary distribution system generally of 3 phase 4 wires. One neutral wire is there. So 3 phases 4 wires. Now for 2022, we have solved the problems of 2023. Now for 2022 problems. All problems are of similar type. So first problem is that about distribution networks. So distribution network radial, yes, and is of unbalanced, is suffer from more faults, yes. So all of these are correct options. So the utility voltage implies to voltage at which load consumed powers. Yes, the utility voltage implies the voltage that at which load consumed powers. The starting point of primary distribution network is substation. Here you can see this starting point of primary distribution substation, while the distribution transformer is connecting the primary distribution network that is operating 11 kV or 33 kV, and the secondary distribution network is operating at 400 volt or 400 line to line or 230 volt single phase, and it is providing to the power to the individuals or customers. The end point of primary distribution network is distribution transformer. A radial distribution feeder 35 nodes consist of. So whatever the number of nodes, that will be number of lines plus 1. So here we are having 3 nodes. So in this example, we are having 3 nodes. So the number of lines is 2 number of lines. So number of nodes equal to number of lines plus 1. So next, the power demand of flowing load is proportional to square of
Can you
voltage.
explain the previous node case again?
Yes. So here we are having 3 number of nodes. It is one of the example. So 3 number of nodes means we are having 2 lines. This one and this one. So in general case, we can say that number of nodes is equal to number of lines plus 1. So the number of nodes is 35 given here. So number of lines will be 35 minus 1, that will be 34. Right?
Okay.
We called nodes in distributed system that we call buses in transmission system. Generally, we use node for the buses.
Okay. Thanks.
So the power demand of flowing load is proportional to sky voltage, that is constant impedance load. And the water heaters are in condition lighting the example. So water heater is the correct answer. Which value of load factor is preferred to utility? So we know this, it is preferred near to unity, and it plays key role in determining the over cost per unit generated. Higher the load factor, lesser will the cost per unit generated. A load factor means higher maximum demand and low utilization rate. And if the load factor very low, the capacity of electrical energy remains inactive for a long time. And we have to improve the load factor so that the demand will be reduced, and it will also reduce the average cost per unit. And this process is known as load balancing or peak saving. Next one is the load factor for this load. So you just find the average demand, and demand is given 100 kilowatts. So 0.5 is correct answer. Here, this is about the load curve and load duration curve. So here the area under load curve is equal to the load duration curve, and that will provide the amount of energy consumption. The last question is that residential customers, we have solved this type problem. So that's all for today's session. I hope you all able to solve the current assignment problem. Is it possible to use calculator during exam? The same have you given the GATE exam? The similar type of calculator will be available in the this course exam. You don't you cannot use the physical calculator. It is virtual calculator, and the similar type of GATE exam, whatever the calculator available in GATE exam, the similar type of calculator available in the GATE exam. Any other doubt? Any other things? I think this time very less number of students. This time more number of the employees. If there is no concern, then we will meet on the next session on Sunday. No, next session on Tuesday, there will be another PMRF. Another PMRF will take the session. On Tuesday, there will be another people. So whatever the people here, means any session you can attend. Means those who are unable to attend today, they can attend Tuesday. But another people will deliver the lecture. Another people will solve the problems on that. Another people will take the tutorial. PPT is available in this book only. I think that that will be shared. Yeah, same topic will deliver on Tuesday, because he has to also he has also signed the same TA work.
Recording of Tuesday's lecture also will be put on the this portal of our operation and planning portal.
Yeah, recording Tuesday is also available, but I would, if you want in a just less time, then I can also give the YouTube link where I will upload today only. From the next session, you can access from the next session. You can access from the from where I can there. I will upload this recording today, and in the YouTube I will also share the link, because SWAYAM portal will take a little bit time. So you can access through the here also. I don't know where from where I can share. I will, but you can search on the YouTube. From the next session, it will be all clear to you, and this SWAYAM portal will also update each and everything. Okay, any other thing?
Okay, sir. Thank you.
Okay, thanks. Sir.
Thank you for attending session, and we will meet on the Sunday. Okay, bye.